But what happens to S when I get a really, really big sample? My sample's huge. Then S is basically the same thing as sigma, so t-score's job is not needed. Then I can just use a z-score. That's what it means when it says large and they are z-scores, because you don't need a t-score anymore. Hopeful. So if z star is greater than 1645, reject the ho, support the high. Right. Good life lessons here in statistics. So what are we going to talk about? What can we use to talk about it? What's going to show enough evidence that my sample gets further away than this? And then, of course, the next step, that makes sense, is where the hell did my sample go? So what do I know from my sample? N is 173. P hat is
58 over 173.
Yeah, it's going to be 58 out of 173. 0.335? 0.335? Okay. Third cubic. And believe it or not, it's all we need to know. We know P and Q. 0.3, 0.7, right? P is 0.3, Q is 0.7. Can you guys see over there? So then I can use my new z-score formula. P hat minus P divided by the square root of PQ over N. This is the part that we stole from the confidence interval. Well, thank you, confidence interval. Cool little confidence interval. And I just got to... Now here's where people can really mess up putting this in the calculator. Just make sure you put the top in parentheses so the calculator knows that's all on the top. And make sure you don't come out of the square root until you get the whole damn thing in there. Let me see. Where'd it go? You can do it, Jeff. 0.335 minus 1. That's what I get, 1.00. Do we make it far enough away? No, we only made it here. We just made it one step up from the mean, which is not very unusual. That could still be where the mean is. Could the mean be wrong? We just found we didn't find enough evidence to say it's wrong. Does that mean the mean is right? Or the percentage. It doesn't mean that percentage is 30%. We just haven't found enough evidence to say it isn't. We have no idea what it really is. Sort of like, measuring crowd size. No? Okay. Probably better to not pay attention to the news. Can somebody find now you're going to love this word and associate with this problem. Can somebody find the p-value? And you're like, there's so many p's up there, Jeff. We haven't found the p-value. P-value.
0.95 to its area below?
No, it's the area in the tail. So if you look up that 1, you're going to get this area. You've got to do 1 minus to get the area in the tail it makes. Wait. What happens? 8413 is that? 1587. So 8413, 1 minus that is 1587. The p-value is 0.1587. And again, that's related to the probability that what we found happened by chance. And that's not a small enough probability to say it wasn't chance. So this whole thing is about, did we find this by chance, or is it more likely that there really is a difference? And that's not small enough to say that there really is a difference. Yeah. Look up 1.00. That'll get the area below, but you want the area in the tail, so you can do 1 minus that. So the p-value is the area of the tail that your z-score makes, your z-star. Just like alpha is the area of the tail that the critical z-score makes, the rejection z-score makes. Beautiful analogy there. So beautiful. So then what's our conclusion? What can we say right here real quick? We didn't make it far enough away, so we failed to reject the hoe. Failed to support the hide. Now, in this case, am I happy about that? What was our claim? Our claim was the hoe, right? So are we happy that we failed to reject? Hell yeah, we're happy. So failure here just means you didn't get far enough away to show evidence against this. And if your stance is this, you're happy. You're happy you failed. Right? So my conclusion, step 5, my conclusion will be, we have not found sufficient evidence. Don't say something like, we have found sufficient evidence to fail to... Come on. Convert all the way to English. We have not found sufficient evidence to... Good. The claim was the hoe. Got to use the hoe language. It's a different class. Good foreign language credits you can get there. We have not found sufficient evidence to reject the claim that at most 30% of women from San Diego participate in the march. All that crap, just put it there. I'm not going to write it again because I already wrote it. Do you see? So just always go back to the problem. Look at the question. That's where you get your language from to answer that conclusion question. All right. While you guys are finishing that up, I'm going to pass out the practice test. And then we'll do the formula sheet, and then we can just do whatever the hell you want to focus on. Sure. Right there. Yeah. Somebody Right. Just do the formula sheet, and then we'll do whatever. Alright, so again, however you want to organize these, as long as you don't put extra words on your sheet, I don't care. So, what was the beautiful thing about these two formulas here?
Your notes.
Yeah, they're notes. When do you use a t-score? Well, when you only know. So I don't allow you to write notes, but I have to let you write formulas, so you get a free note if you know how to read. Read this language anyway, right? And then of course you got p hat, plus or minus. And what's the giveaway here, really, to understand There's no second p hat formula, is there? So that's a note saying you only use freaking z-scores with the NP3 problems. Alright, so there are only two more formulas from chapter 8. They were the sample size formulas, remember that? This guy here, however you want to write it. And then the associated one for p hat, q hat.
So we could write it the way we want it as long as it's just the formula, right?
Yep. So you can put those together, you can put this together with that, whatever the hell you want to do. And then you've already got these formulas somewhere, but you might as well put them again. And you've got this guy here. You got this guy here. You got this new one we just did today. Right? Is it cool? And just because, now, do not write this last one if you don't plan on looking at section 10.1. Just to show you, though.
Can't we if we want it?
Of course. But
I just want to make sure.
I don't want you to look at it and use it when you're not going to do the bonus question about 10.1. You're going to use it some other freaky place. Don't do that to yourself. Real quick, notice here how there's only one sample, right? So here there's going to be the difference between two samples. How far apart are those two samples? So you're trying to see, if I take a sample, there's a little more to this equation that I'm sort of bypassing for now, obviously, because there's no time to talk about it. But I want to see it, basically I want to see, given one sample and the other sample, are they far enough apart to say that they're different? So that's what this formula ends up being, is a distance between two samples. Are they far enough apart to say that they really are different? So the bottom is going to be, here's where it gets a little bit freaky. Well, it's already freaky. So I need two standard deviations, don't I? And to be honest, normally it's going to be S's, so I'm just going to put that. So it's just a bigger z-score formula. Poor little dude's got to be bigger because it's got to fit two samples worth of information in, right? But again, if you don't, that might be enough to convince somebody maybe not to do this section. But
It's really
the
not-
5 steps are the same 5 freaking steps. It's just on step 4 you use that formula and you just plug all the shit in that they tell you. It's crazy.
So that standard deviation from Formula 1, or from, right? And then that one's 2 squared.
This is the sample 1
Sample 1 squared.
mean, sample 1 standard deviation, sample 1 size, sample 2 standard deviation, sample 2 size. Yep.
It's not as
So is it only like the numerator that's being squared in each
Yeah,
one?
because real quick, definitely don't write this down. Screw it, you're gonna write it down. Oh well, it's your fault if you don't listen to me. What do I square root to get sigma? Square root of what is sigma? Square root of sigma squared. So could I just make that's the same thing? These are the same. And if I put an S there because I don't know sigma, and then I have 2 of them because there's 2 samples,
Okay.
that's where it comes from. All right, that's enough about 10.1.
We're not allowed to write the S.
Say again?
We're not allowed to write the S formula on that.
What S
Want us to
formula?
replace it in our own brain.
Oh, if you want to write this, you can.
Can we?
I just didn't even think about it.
Okay, good.
You can write that if you want to,
Yeah,
sure.
okay, good. Thank you. That's what I need.
Of course. That is a formula. You can write that down. I like it. Just don't bullshit. Now let's gloss some other stuff. Sure.
That top end, that's z squared and then sigma squared, correct?
Oh, here.
Yes.
Z squared, sigma squared, E squared. Yeah. Or of course you could write Z sigma over E, all of that squared, whatever way you like better. They're both the same thing, right? Distribute the square or don't distribute the square. and squared is spare. Cycle.
Are we gonna have to use that?
What do you mean? Sure. Yes. Okay. So, if you really, really want to, you can pretend like there's a new formula for t. But guess what?
It's the same. I know.
It
But
really is the same. It's just got.
I know, but can
Yeah.
we do it?
Of course. There it is. T star and Z star measure the exact same thing. They measure how many standard deviations away from the mean your sample ended up. It's just that the T star, of course, is going to use. That's why I need T's if I only know S, right? But I still got to change the SX bar.
So we write down the T star rules.
If you want to, yeah, sure, you can. Okay, so now it's wide open to whatever you guys want to do. If you want to take a break, feel free anytime. You want to get together with other people and work together on the practice test, you can do that. If you want to curl up in the corner of fetal position, you can do that. Yeah, you didn't even have to be here, so if you want to leave, you can. This is college. So, show up, huh? Yes. Or you gotta head out?
I'm not sure yet.
Okay.
Do you care if I I really like this just because of anyone at home.
Oh, I see. Sure.
But can I write it like that also?
Sure. Of course. Yeah.